So welcome everyone back for the class on Introduction to Comparators. So in the last session we saw about the second module related to the shaft and the hole basis design with the go and not go gauges as well, the applications, all those steps. So now let us throw some light on exactly what do you mean by comparators, what are the use of comparators in our subject mechanical and measurement system. So this lecture deals basically on introduction to comparators, what is the basic principle behind, what are the uses of the comparators, what are the characteristics of the comparators, and what are the major classifications related to the comparators. So before proceeding further, one has to know what do you mean by an comparator. So comparator is nothing but in simple statement we can say it as an precision instrument. So now again the question arises, what do you mean by precision instrument? So we have dealt about the precision and accuracy in the module 1 already, so where we have focused on difference between accuracy and precision also. The same concept has been related here for the precision instrument. So a comparator is a precision instrument in the sense it is a precision instrument which helps to get the values almost closed or nearer to the actual measurement. So you can check how precise the instrument can measure the given part. Suppose you have a part of a rectangular piece which has been measured into 10 by 5 and 5 times also you measure and you get the same value. That shows that how precise the instrument is in measuring the closeness value of the given part. It could be even weight, the weight of a human being cross-checked 5 times, and every time if the person weighs of around 65 kg only, then that shows that the instrument is very precise in measuring to the nearest value of a part or in body, whatever it is. So the comparator is used as a precision instrument in order to measure the closeness to that of the existing part. So this helps in measuring the dimension very precisely. So with this background, always we can say that comparator is used to compare the dimensions of a given object of component with given standard. So what do you mean by it? It is employed to compare the dimension of a given component with the given standard. Usually in order to compare in a precision instrument, some standard will be given. So standard is the actual pakka information with all dimensions and specifications. So this standard will be used in order to compare its dimension by using the comparator to check how close it is to the given object. And it is also employed to find out by how much the dimension of the given component differ from that of an known datum. So the known datum is nothing but it speaks about the datum line, the zero line or the basic dimension of the given part, and in comparison related to what is the difference you are getting with respect to the datum or the reference or the basic line to that of the measured component. So it can be used to measure the closeness, how close the measurement is to the given part, and also it is helpful to determine the difference between the basic dimension and the value what you are getting when you use it to get the precise value. So this is the basic principle what we use. So first we use so here it shows the dial indicator, and you will be having a plunger which moves on the standard, and accordingly the H1 you will be knowing the height of the standard, how much it is, and here if the plunger shows no deviation and this height is almost equal to it, there is no error in the deviation. And later after measuring the standard, then you will place the workpiece uh, in the place of the standard and you will measure the dimension. The plunger moves on. So while moving, if you find any deviation in the dial indicator, then it shows that there are some difference with respect to the standard and that of the workpiece. So that difference will be determined by taking the difference of H2 minus H1. So this deviation which helps in providing the difference between the standard and the workpiece, and also it helps to check how accurate the given standard is by using an comparator as a precision instrument. The two theoretically what we explained is now here focused in the image way, where you can clearly identify in the first thing you are comparing a standard where the deviation is 0, that shows it is very precise in measuring. Then you remove the standard and you will replace with the workpiece, and again you measure, then you find the difference. So the difference between these two will provide the difference value with respect to the standard and the precise value what you are getting. So after understanding what you mean by the comparator, it is essential to understand the concept or the principle behind how an comparator works. So initially the comparator is always adjusted to 0 on its dial with a standard job position. Then the reading H1 will be taken with the help of a plunger. So this is nothing but the explanation of the diagram which was given before. So then the standard job is replaced by the workpiece to be checked, and the reading H2 is taken. Then you take the difference between H1 and H2, which characterize the difference in the dimension as it is displayed in the dial indicator. Okay, so after understanding the basic principle of the comparators, you should know where these are used basically. The comparators can be used as in laboratory standards in order to compare the component what you are testing, you are manufacturing, you are synthesizing, relevant to different streams of engineering, or even the basic physics or chemistry labs as well. It can be used as an working gauges to measure the linear measurements, sometimes angular also, or the contour part of it based on the requirement. And finally, it can be used as an inspection gauges also. Comparators could be used as an inspection gauges in order to inspect whether the part manufactured lies within the tolerance range or not. It could be also used as receiving inspection gauges to get the data extracted from the inspection gauges, and also for checking newly purchased gauges. Suppose you have purchased some new gauges, you should be having some standard to compare how precise it is, right? So I have told you in the last session already, as the part has the tolerance range, even the gauges will be having the tolerance range. You remember? Yeah, so in order to check, so it is very essential to have some comparison with the standards. So these gauges will be checked with some standards by using the comparators. So it will be helpful in all these ways as an standard part to measure its values. After this, you should also be understanding the various characteristics of the comparators. So various characteristics are, one of it is the robust design and construction. The comparators are of a good robust design and construction, and then it is having linear characteristics of scale. It has high magnification, it is quick in results, it is versatile, and it is focusing on less amount related to minimum wear of contact point. So what all these points indicate? The design concept of comparator is robust. Okay, and apart from that, the construction of it is not too complicated. And further, linear characteristics of the scale. So it could be used for linear measurements related to its characteristics of any type of scale which is in need. It could be used for high magnification purpose. So these comparators help in identifying and determining the values at high magnification scale as well. And comparators yield us the result very quickly. It is very versatile in nature, and the where what we come across while operating on comparator equipment is not too high at the contact point between the standard to the plunger or between the workpiece to the plunger, yeah, whatever it is. So these are the few important characteristics of the comparator. If they ask you, you should list out and be able to explain each individually, at least brief it out in a proper way. And also the comparators are free from oscillations and backlash are not generated while using, and you can insert the workpiece quickly, there is no complication in it, and you can use an adjustable table so that the grip between the plunger and the workpiece which is connected to the dial indicator will be easily to push up and pull down the workpiece or the standard. Compensation from temperature effects. It's are not affected with the temperature, so importantly, but the compensation from temperature effects could be overcome, and also it means to prevent damage. The damage to the workpiece or to the standard is very less while using the comparator, as there will be a smooth flow of movement between the workpiece or the standard with the plunger. So these were the characteristics of comparator. So after knowing what you mean by comparator, why it is used, what are its main characteristics, and one will be interested to know about the classifications also, right? So there are different types of classification. In this lecture, we are focusing about the classification related to mechanical comparators. So in mechanical comparators, there are again subdivisions where we can focus on dial indicator, read type comparator, sigma comparator, Johannsson Mikrokator comparator, and mechanical optical comparator. But in our syllabus related to mechanical comparators, we have in-depth description for dial indicator, sigma comparator, and Johannsson Mikrokator comparator. Okay, so now we have to know about what do you mean by mechanical comparators before going to its classification. Okay, so these mechanical comparators are self-controlled and no power or any other form of energy is required in order to operate mechanical comparators. So this thing you have to remember. So when it is told to be as a mechanical power comparator, you are not using any external source of power, because the comparator is self-controlled by itself. So how does it operate? It employs a mechanical means for magnifying the small movement of the measuring stylus, because the measuring stylus is very low, slow, and a small movement only it is being made. So it employs certain mechanical means which is able to sense the small movement of the measuring stylus. So no need of external power is related to this. So the movement is mainly due to the difference between the standard and the actual dimension being checked. So this movement occurs due to the variation between the difference of the standard and the actual, because first you will keep the standard and you will measure. So there will be no deviation because it is accurate and precise as well as per that standard thing. And now when you remove that standard and insert an workpiece, and if the workpiece is not exact into the dimension of the standard, obviously there will be a slight movement in the measuring stylus of the dial indicator. So the dial indicator can come down or go above due to the variation in the dimension of the workpiece. So this small movement will help us as a mechanical means in order to show the deviation in the dial indicator either towards the positive or towards the negative. So here we can make out and dial indicator. So you will be having a top at the dial indicator called to be as an cap, and you will be having an scroll type of thing with which you can make the fine adjustment. So this is the outer frame, okay, and you will be having a limiter at the top and corner, and you will be having a shorthand inside, okay. So this is a long hand for the dial indicator, and you will be having a scale mark plate where the scales are being graduated, and this the lower part of the dial indicator is called as a stem, and the upper part is called as a cap. So you'll be having a spindle on which it could be rotated, and you'll be having a gauge head at the bottom. So this gauge head, which acts as a plunger, will be moved. Yeah, gauge head will be connected. So this will be the plunger. Okay, so when the plunger is moved on the workpiece, so you will be having a pointer in the dial indicator which slightly moves down or back. So here there will be a rack and pinion arrangement within the comparator. So due to this movement, this rack and pinion measurement will help in moving the pointer towards the right or the right or the left. So this is the mechanical means what we were telling, by which it helps in moving the movement of the stylus is nothing but the rack and pinion mechanism. I hope you are very familiar with the rack and pinion mechanism, which helps in movement with respect to the rack and the pinion with engaging of gear 1 and gear 2 respectively. Okay. So this was about how a mechanical comparator works. Then I was telling, under mechanical comparator we have different types. In that, the first one is nothing but our dial indicator. So now you should now understand how a dial indicator works. So it operates on the principle that a very slight upward pressure on the spindle at the contact point is multiplied through a system of gears and levers. So that's what it operates in the same way what we told with respect to the gears and levers. So it is indicated on the face of the dial by a dial finger. So this movement is indicated in the face of the dial because they'll be having a dial finger which will be pointed long like a needle. So this dial indicator basically consists of a body with a round graduated dial and a contact pin connected with a spiral gear train to the hand of the dial face indicates. Gear train, so that the hand on the dial face indicates the amount of movement of the contact pin. So it is nothing but the dial indicator. You have seen already how does it look. It will be having a graduated dial, and it will be having a contacted pin with a spiral or the gear train backside, so that the hand on the dial face, helps in identifying the amount of movement of the contact point. I'll show the diagram in the next slide. So they are designed for use of wide range of standard measuring device. It's not for one or two, it could be used for a wide range of measuring devices such as dial box gauges, portal dial, hand gauges, dial depth gauges, diameter gauges, and also dial indicator snap gauges. So it could be used in various ways depending upon the requirement. So then you should know what are the applications of the dial indicator. So applications are, it is used to compare the heights or the distance between the narrow limits, and also to determine errors in the given geometrical forms. Apart from linear and angular measurements, even geometrical forms are also there where we measured the measurements, and if any error associated with it, also it is helpful for testing alignments such as roundness and parallelism of workpiece. And it also helps in checking whether the alignment is proper, the roundness what we are measuring, is it accurate, and if the parallelism of the workpiece is proper enough. It also helped us in inspection purpose also, so where quality control plays an vital role. It is also used to check the alignment of the lathe centers before we operate it for various operations by using suitable accurate bars between the live and the dead centers in case of lathe. It is also used to check the trueness of the milling machine adverse and also to check the parallelism of sharp arm with table surface. So if they ask you the application part, so you can list out these application in any other application if you feel like, which are seen in day-to-day lives. You can add on to the list as per your best of knowledge. Okay. So this was about the dial indicator. So dial indicator diagram was also been shown, and now next is Johannsson Mikrokator. So this is the second type of mechanical comparator which is being used. So now we have to understand what is the principle behind Johannson Mikrokator. So it works on the principle of an button spring, spinning on a loop of a string, like in case of an children's toy. So many toys are there where it helps the toys to spin with a particular loop with the help of a string. Okay, so that spinning movement, how it come across by the loop of a string in case of children toy, the same concept is being used in case of Johannson Mikrokator comparator. Okay, so when a tension is applied to the twisted strip, it causes the strip to untwist, resulting in rotation of the pointer, which is attached at the center of the twisted strip. So this is the basic principle. So whenever you have a tension in the twisted strip, it causes, what happens? It causes the strip to untwist due to the tension. So this results in rotation of the pointer of your Johannsson Mikrokator, which is attached at the center of the twisted strip, and this deviation will explain how much rotation it has rotated depending upon the tension which is applied on the twisted strip. So this is also a type of mechanical means through which the indicator moves, and you can know the deviation from the standard to that of the workpiece. So even here in this case, no external power source has been used in order to determine how precise the given workpiece is. Okay. So now you should know the construction part of an Johannsson Mikrokator. So it employs a twisted metal strip, and any pull on the strip causes the center of the strip to rotate. So we have explained this already. So if any pull is applied on the strip, it starts rotating. Okay, so a very light pointer made of glass tube is attached at the center of the twisted metal strip. So first we told it has a twisted metal strip. So any pull on that strip will make it to rotate. Further, at the twisted metal strip, you have a very light pointer and it is made up of glass tube. So this pointer is attached to the center of the twisted metal strip, and then the measuring plunges on the slit washer and transmits its motion through the bell crank lever to the twisted metal strip. Later this is employed with a plunger. So this plunger, which is present on the washer, will transmit the rotation motion to the bell crank lever mechanism, which is being used in this comparator for twisting the metal strip. Okay, in previous one it was the which mechanism? Rack and pinion mechanism which was being used, and here it is the bell crank lever mechanism which has been used to achieve the twisted metal strip. So the other end of the twisted metal strip is fastened to the cantilever strip. The overhanging length of the cantilever strip can be varied to adjust the magnification of the instrument. So the longer the length of the cantilever, the more we can get deflected under the pull of the twisted metal strip, and less rotations of the thing based on the rotations what we get. Okay, so here you can see, so if the plunger moves a very small distance in upward direction, the bell crank lever turns to the right hand side. This you have to be careful. So when the plunger moves by a small distance in the upward direction, okay, and then the bell crank lever turns towards the right hand side. So this and vice versa. So this exerts a force on the twisted strip. So due to this force, what happens? It causes a change in the length by making it further twist or untwist. So depending upon the situation, it could either twist or untwist. Hence the pointer at the center rotates by some amount. And here magnification up to 5000x can be obtained by this comparator. So this is the diagram of the Johannsson Mikrokator. So at the bottom you will be having an plunger. So here you will be having a slit washer. So this is the light pointer what we explained, a glasser one which is placed. So this is the bell crank lever mechanism, and this is the twisted strip which has been employed, and here will be the cantilever strip. So based on the movement of this plunger on the workpiece, so what happens is you have a slitter washer. So with this movement will help in getting the required movement of the bell crank lever mechanism. Based on the pressure applied, this twisted strip will rotate, and due to this rotation, the deviation what we get will be measured in the light pointer. Okay, so this is how it operates. In reality, it looks like this. The image of an Johannsson Mikrokator, it looks in this way. And next type of mechanical comparator, what we have to understand is sigma comparator. Okay, the sigma comparator has two parts, section A and B. Before going in depth, you can just see here also you'll be having a plunger, a jaw will be placed here, you'll be having a bending plates at both the sides. So this will be an rectangular block what we'll be having, and this part is called as a knife edge, and you will be having a sapphire plate here and a moving block which could be moved with the help of a cross strip you have. And then the top positions here are placed with again the bending plate over here, and here you have a dial indicator with a pointer, and this is the driving drum based on the movement, and this is the arm which can be moving block. Okay, so this moving block here has been magnified, so where you'll be having a fixed box. Okay, so here it will be the force applied. Based on the force applied, this block could be movable in this direction. So based on the movement of the block here, the pointer will be rotated to show the deviation. So this rotate based on the movement of the plunger. So when the plunger moves on the job, the variation here will result due to the application of the force, and that force will help in the movement of the pointer and get the required deviation of variation when it is used to measure and workpiece rather than that of an standard. So first you have to understand the basic principle. So it works on leverage principle, in which high magnification is obtained as in case of Johnson also. So here the bar is restricted to move in only vertical direction. Remember, a knife edge is fixed at the bar. So you have a bar in the vertical direction and a knife edge is fixed to the bar towards your right. So the knife as shown in the figure before. So the knife edge is attached to the sapphire plate which is attached to the moving block. I explained you already, the knife edge exerts a force on the moving block through the sapphire plate. So the moving block is attached to the fixed block with the help of the cross strips as shown in the figure B. So when the force is applied on the moving block, it will give an angular deflection. Due to this angular deflection, the Y-arm which is attached to the moving block transmits the rotary motion to the driving drum of radius R. So this deflects the pointer and the reading is noted. So this is how the sigma comparator operates. So the distance from the hinge pivot to the knife edge will be measured as I, and L will be the length of the Y arm which has been used in sigma comparator. So R will provide you the driving drum radius. So D will be the length of the pointer exactly. Then the total magnification will be calculated by length of the arm divided by distance of the hinge pivot to the knife edge into length of the pointer divided by the driving drum radius. So this provides the total magnification value of the sigma comparator. So this is how a sigma comparator looks like in actual. So then you have to know what are the advantages of comparators. Uh, Advantages of comparators are it do not require any external source of energy. As it is told, it uses the mechanical means to operate and no power source is required, and it is comparatively cheaper and portable when compared with that of other type of comparators. We'll speak about the other type of comparators in the next session. And it is robust in construction and very compact in design also. So the design part is robust and compact in nature, and the simple linear scales are easy to read. It is not complicated and also unaffected by variations due to external source. Suppose if the instrument is kept very near to air where it is breezing very highly at a higher speed, and also electrical effect will also not make any changes in the measurements related to mechanical comparators. And then you should know about what are the disadvantages of the comparators also. So here when it comes to range, so range is limited as the pointers move over a fixed scale. There is no like flexible or in scale of for longer deviations, both positive and negative. It can move only until the fixed scale. If there are deviation beyond that also, these comparators will not be able to measure. The pointer scale system, next is the pointer scale system used can cause parallax errors because you won't be able to get an exact reading due to parallax type of errors associated in the mechanical comparators. There are a number of moving parts in mechanical comparators, so this may create problems due to friction, and ultimately the accuracy might also be less. So this is one of the major drawback in mechanical comparators due to many moving parts. We have many moving parts because due to the mechanical means which is needed to make the pointer to show the deflections. If any external power source would have been used, then many moving parts may not be in existence in a comparator. But since it is a mechanical comparator, it has to have a certain moving parts to get the mechanical means of motion. And as a result of this mechanical means of motion, friction might arise, and due to which the accuracy can also come down a little bit. So this is one of the major thing one has to think about before using mechanical comparators. And further, the instrument may become very sensitive to vibration due to high inertia. So these components have high inertia thing. So due to this, it is very sensitive, and even minor vibrations can also result in major deviations in the dial indicator. So these two are the major drawbacks related to the mechanical type of comparators. So this was about a brief introduction about what do you mean by a comparator, why it is used, what are its classifications, its characteristics and application as well. So I hope you have understood the basic concept of comparators, and in the next session we'll be dealing about the other type of comparators. We have focused on mechanical comparator in this session only. So other chemical and the pneumatic type of comparators will be dealt in the next session. So please go through it and prepare well. Any doubts, you are always free to ask. Yeah, thank you. Bye-bye.